Hello and welcome to the Chapter 9 review. We're going to be looking through problems 119 through 122, and then 134, and then 140 to 143. First one's asking for the equations to the piecewise function when they give you the graph. So here's the graph. I drew the red piece over here, the blue piece here. So the red graph, if we were to continue it and extend it, it would go right through here, and it would be the equation y equals 1x plus 1. But we only need that part for when x is greater than or equal to 2. The blue part is the line with the y-intercept of -3 and a slope of 2. So this would be the equation y equals 2x plus 3, but we only need the part when it's less than 2, not equal to 2 because it's an open circle there. So two parts of the graph, it's this when it's above 2, this when it's below 2. Here we have a probability question. So we've got 3 reds, and if they draw a red, they win $3. So 3 out of 12 is the probability of that happening. The prize is $3. The blue, they lose $1. There are 7 out of 12 chances to lose $1, and then the yellow is 2 out of 12 that they win $10. From here, I just multiplied. Here gives 9, -7, and 20. I added those up and got 22/12, which is 11/6, which is $1.83. So is this a fair game? Well, it would only be fair if this equals 0. Because this equals positive $1.83, that means that the advantage has the student. On average, over the long run, he's going to win $1.83 every time he plays. Now this is a key question here for your review. We've got this rocket. It's modeled by this equation. And we're trying to find how long after the launch does the rocket reach the ground. So the first thing to do is to let the height equal 0, because we know on the ground the height will be 0. And then from here you could do quadratic formula and add 0 and do a's, b's, and c's. I chose to do factoring, and the thing to do with factoring on every factoring problem all the time, no matter what, is look for a greatest common factor. This has a greatest common factor of 4t, so I divided the 4t out of both of them. That leaves this left over. And then zero product property, two things are being multiplied together to equal 0. So this equals 0 or that equals 0. And if you solve it, we get 5.75. So the two x-intercepts are 0 and 5.75. Those are the times whenever it's on the ground. Then it says, write and solve an inequality that shows when the rocket is at least 76 feet high. So I made this rocket at least 76 feet high. I subtracted it. This time I used quadratic formula, plugged it all in, simplified, got 3,600 here, which is 60. And then we did the -92 plus 60 over here, the -92 minus 60 over here, and I got 1 and 4.75. So the time that it's over 76 feet is between 1 and 4.75. So if you think about this, here's kind of our 76 feet. It hits it at 1, it hits it, and it stays above it until we get to 4.75 seconds. So in order to qualify, the rocket must be at least 76 feet off the ground for 4 seconds. Does it qualify? So I plugged in 4 here. And I got, yes, this is bigger than that, so yes, this works. What's an appropriate domain? Well, the domain is a set of all the x values that make sense here. In this case, we don't need negatives for time. The only x values that really make sense are from 0 to 5.75. 22. Now we're given a graph with some information and we're asked to write an equation. So here's my starting point. I look at the x-intercepts, and I know this means we're going to have x plus 9 and x minus 5. These are the zeros, right? These are the x-intercepts. And I have the a value. I don't know that front number. But then they give me one other number here. So I plug in this for x and this for y in my equation, and I solve it for a. And I got -0.225 for a, so that becomes my front number. So I write the a value and then x plus 9 and x minus 5. Kind of the same thing here. They give me x-intercepts, so here's my starting equation. I don't know a. I plugged in the x and y of the vertex. You can plug in the x and y at any point and that will work. So I plugged in this for y, or for x, here and here. I plugged in this for y. I figured this out, I solved it, and I got 2 for the a value. So here's my answer. The 2 is the front number, x plus 7, x plus 4. Over here, Again, I set it up as a starting equation. They give me this, so I plugged in 0 for x and 12 for y, and I solved this and I got 1/3. So 1/3 x plus 6 squared. This is the checkpoint problem, so this is kind of what we should be able to do at this point. Make a table and draw a graph. So here's a table of points. I plotted the x-intercepts, I plotted the vertex. This is generally what that's going to look like. B is write a possible equation for the graph. Well, I know my x-intercepts are 2 and 5. I don't know the a value, but I know it opens up. So here, that's a possible equation. If I knew the points more specifically, I could figure out the a value, but they don't really tell me exactly where the vertex is or any other points that are on the graph. In C, without making a table, what are the x-intercepts? So I factored this. I factored this and I set it up so x is -7 and x is -4. Then I could average those to find the middle. And then when I plug it back in, I found the middle and the y value was -9. And D says the height, what's the maximum height? So I factored this, greatest common factor. I pulled out a 16x, and that left this left over. And then zero product property, I can split this and split that. So I get 0 and 8. I can average those to find the middle, which is 4. And then I plugged that back in, and I found that when the vertex was 4, the height was 256. So there's the answer there. You can average to find the middle. At 140, just keep everybody out until I'm done for a second. 140, well, we're setting these equal to each other. So first is equal to each other, then make it equal to 0. So I moved all this over here. I divided by 2, because there's a greatest common factor. And then when you divide by 2, 0 divided by 2 is still 0. I factored this. I set those equal to 0 to find my x values. And then I plugged it back in. Plugged in 3 and I got 2. I plugged in 1 and I got 2. So one answer is 3, 2. The other answer is 1, 2. Over here, same thing. I made them equal to each other. Then I made that equal to 0. And greatest common factor of 3, I divided. This only has one x-intercept. I plugged it in and I got 0. So my answer is 1, 0. That was the x-intercept. Here we've got part A. The first one is we're subtracting 1, so the whole thing is shifted down 1. This one is a negative in front, so that's going to flip it upside down. And this one is subtracting 1 on the inside, which is going to slide everything right 1. So this is just shifted over 1. And here, this is a piecewise thing. I said that it's 50 for the first 6 children. You can't have 0 children. And then after that, we know it's going to go up by 5, and I figured out that for each extra child, it would work on this. So it's going to be a straight line, and then a line after that going up. The expenses are $3 per kid. You can find the net profit with the money you bring in minus your expenses. On the test, I won't ask you something like this, but this is how we could take those two things and combine them to get net profit. But if you got that wrong, don't worry about part D for right now. 143, this is a core problem. This is one you should be able to do. To find the vertex form, I completed the square. I added the 16 and subtracted 16. And that gave me my vertex form, so there's my vertex. To find the x-intercepts, I did factoring. I did greatest common factor. X is 0 or x is -8. So there's my x-intercepts. Here's my vertex. And there's my graph. I hope that helps. Have a great day.